Imagine if the most dazzling guest streaking through our heavens turns out to be more than a mere icy drifter, perhaps a signal from afar. Comet 3I/Atlas stands apart from the crowd. Its trajectory, arrival, and that eerie pass by Mars have sparked puzzles that defy simple answers. Detectors caught subtle waves in the surrounding particles, hints of fragments that seem organized rather than haphazard. Might this be a spark of existence hurled through the galaxy? Or a device masked in frost? The more we probe, the odder it gets. This evening, we dissect the proof, the gossip, and the chilling possibilities. After all, if 3I/Atlas defies chance, so might our destiny. And a weighty query lingers. If the whispers hold water, how much time do we truly have left? Stick around to the finish. What emerges isn't solely about this celestial body. It's about humanity and forces possibly already underway. Part 1. The newest development. An entity breached Mars' path on October 3, 2025, and countless folks believe we're getting the runaround on its true nature. Dubbed 3I/Atlas officially, it's the third verified outsider to enter our solar neighborhood. Originating from realms far outside the stars, a journey spanning millions or billions of years. Now it's hurtling sunward at velocities that would incinerate any probe we've engineered. Official experts label it a comet, likely frozen water and stone draped in grit, obeying the universal laws that dictate all other chilled nomads in the void. They dismiss odd signals as equipment glitches, optical illusions, or data interference. They claim we're projecting our hopes onto shadows. But then the photo surfaces. On October 5, 2025, a blurry clip popped up across social platforms, supposedly snagged by the Perseverance rover on Mars amid the close approach. The video depicts a faint line slicing through the starry backdrop, typical for observational shots, save for a single detail. The line exhibits form, several aligned streaks, nearly symmetrical, advancing in flawless sync. In just 6 hours, it racked up 17 million views. By the 12-hour mark, NASA released a denial, branding it a digital error, a flaw in the data handling code that spawns illusory shapes in cluttered feeds. Come the 24-hour point, 3 additional purported shots emerged from varied outlets, each displaying comparable structured designs. The web reacted in classic fashion, total frenzy. Hobby stargazers dove into every scrap of open info. Online astro communities buzzed with breakdown posts. One individual fed the visuals into AI for spotting patterns, the kind used to monitor orbits. The tool highlighted irregularities. No smoking gun, but sufficient to fan the flames. Enough to question why NASA jumped in so swiftly and sharply, if it was truly mere static. Here's the solid ground we stand on. 3I/Atlas was spotted in November 2023 via the Asteroid Terrestrial Impact Last Alert System in Hawaii, the outfit that alerts us to looming threats from space rocks. Initially, skywatchers pegged it as a typical extended orbit comet from our Oort cloud, that enormous shell of frosty remnants encircling our system like a starry blizzard dome. Yet as data piled up, the course sharpened into focus. This wasn't a local. Its speed was excessive. The Arc 2 curved for bound travel. It hailed from between the stars, joining the elite trio alongside 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Yet 3I/Atlas diverges from its forerunners in key respects. Oumuamua was minuscule, perhaps a few hundred meters, spinning erratically like a stellar stogie or a disk, per competing theories. It displayed odd speeding up as it exited our system, a subtle nudge beyond what venting gases could account for. The usual mechanism where surface ices sublimate into vapor, generating propulsion. Researchers floated various earthly causes, from icy hydrogen to stellar particle push, but nothing clicked seamlessly. Then it slipped past Neptune into the black, evading deeper scrutiny and spawning endless riddles. 2I/Borisov played nicer, resembling a textbook visitor from our own domain, outwardly and behaviorally. It sported a clear coma, that hazy envelope of vapor and particles around the core. Its tail streamed sunward as predicted. It stuck to protocol. Experts exhaled in comfort. Order restored to the cosmos. Enter 3I/Atlas. And suddenly norms start to warp. The buzz began subtly, murmurs among scholars that the path held subtle quirks. Watchers observed it holding steady more than anticipated, based on projected mass and makeup. A few asserted the speed flickered in tiny ways that clashed with standard models. Pure gravitational motion. Those subtle differences were minuscule, easily lost in the noise of measurement uncertainties, yet they persisted. Or perhaps they didn't. The broad error margins concealed a range of possible readings, fueling the tension in this pivotal discovery. Next, the weight assessments arrived, complicating matters further. Preliminary figures indicated that 3I Atlas could be far bulkier than first anticipated, potentially magnitudes heavier than Mua. Should that hold, it flips the script entirely. A denser body demands greater thrust to shift its course, rendering any oddities in its orbit tougher to attribute solely to natural forces. Moreover, collision risks escalate dramatically in severity, even if the present path avoids Earth for now. The encounter with Mars aimed to clarify these uncertainties. During its nearest pass, 3I Atlas came within about 5 million kilometers of the rusty world, near enough for various satellites to scrutinize it in exquisite detail. The veteran Mars Express from the European Space Agency, the trace gas orbiter equipped with cutting-edge spectrometers, NASA's MAVEN probing the planet's air layers, the Mars Reconnaissance Orbiter boasting its potent high-res imager, and even Perseverance on the ground, tilting its lenses upward. Virtually every key observer around Mars fixed its gaze on the intruder. Then, the anticipation built for the incoming observations. That's when the wild theories gained traction. In our era of real-time updates, even brief pauses raise eyebrows. Folks overlook that signals from deep space travel at light speed. Impressive, until you factor in Mars's current distance of roughly 200 million kilometers, so transmissions lag by about 11 minutes one way. Factor in data packing, analysis periods, alignment verifications, and remember these spacecraft weren't built for snap astrophotography, and holdups are unavoidable. But logic rarely quells conjecture. Unofficial photos surfaced ahead of formal announcements, a clear warning sign in hindsight. Genuine research undergoes rigorous checks before going public, just to prevent bogus claims. Yet in the public arena, established outlets seem glacial. Whether genuine or cooked up, those circulated shots rushed into the informational void left by cautious experts. NASA's rebuttal came quick and precise, pointing to familiar glitches like JPEG artifacts, sensor strikes from cosmic rays, and faulty pixels that can fake outlines in dim conditions. Every bit of that rings true. It occurs all the time, and it offers ideal camouflage if someone's concealing genuine evidence. Still, if the whispers pan out, what's our time frame? It hinges on 3I Atlas's true nature and purpose. The outlook for humanity varies wildly based on whether this is a random icy wanderer or an entity with design. A standard comet will swing by, perhaps dazzling us from afar before fading into the void. A scout craft could mirror that behavior, collecting intel for far-off builders. Or its agenda might run deeper. Time's ticking. Closest solar approach looms. The star beckons. Soon we'll discern if this was mere static or a genuine alert. Part 2. Fracture and Lure. Weight counts. An item's heft reveals its gravity, literally. Fresh evaluations imply we might have lowballed 3I Atlas right from the start. Early guesses pegged it in the ballpark of ordinary long-period comets, perhaps a handful of kilometers wide, tipping the scales at billions of tons, unremarkable on a stellar scale. Those numbers drew from luminosity data paired with guessed reflectivity rates, or albedo. It's like sizing a soot-covered lump in pitch blackness via a bounced-back light ray. Yet as 3I Atlas drew nearer and additional scopes tracked its path, the equations began to waver. The thing gleamed more intensely in select spectrum bands, fainter in rest. Feeding the revised inputs into polished simulations, scientists watched the size projections soar. Certain models now propose 3I Atlas might outweigh Oumuamua by a factor of 10 or beyond. That reshapes the debate. When a hefty mass displays trajectory quirks, dismissing them as mere venting from sublimating ices grows increasingly implausible. The volume of expelled material required to nudge such a behemoth borders on the ridiculous. For context, Oumuamua clocked in at around 100 meters long and 400,000 tons. For something that compact, its bizarre speedup could plausibly stem from hydrogen ice release. The figures strained credulity, but they worked. Now, upscale to 3i Atlas. If the latest projections hold, the figures check out, and with estimates hovering around tens of billions of tons, the amount of gas release needed for even slight path corrections turns out to be mind-boggling. You'd have to expel substance at levels detectable by any observatory aimed its way. The surrounding haze would be massive, the streaming trail dazzling. Parts of this are indeed occurring. 3 Atlas has formed a haze and trail, no doubt. Yet the link between the detected gas emissions and the object's steady path feels mismatched. It's akin to observing a freighter executing sharp dockside turns without any apparent helper vessels nearby. The calculations just don't fully align. The makeup's density emerges as the key puzzle. What exactly composes 3-eyed Atlas? A scattered debris heap might possess fairly light density, perhaps double that of water, aligning with standard comet cores. However, should this entity cram mass into a tighter space than comet stuff typically permits, we're dealing with a radically altered makeup. Metallic elements have been floated as a possibility. Not solid metal, but a metallic heart encased in a frozen coating. Imagine it as stellar plating, a shielding coat enabling a compact inner framework to endure the trek across starless voids. Real metal-laden space rocks do exist, leftovers from busted worlds. An interstellar wanderer of that sort isn't out of the question. But one cloaked in comet-like trappings begins to shift from celestial study toward crafted design. Online theorists have grabbed hold of concepts like an artificial casing, an intentionally built exterior meant to imitate a genuine comet while safeguarding inner cargo on a voyage spanning eons. Researchers have sketched out comparable setups for our own deep space explorers, employing frozen barriers to shield sensitive gear from galactic rays and hydrogen specks that turn lethal at near-light velocities. The phrase nomadic rock vessel has crept into discussions, blending an asteroid's shielding bulk with a probe's intentional route. Under this view, 3 Atlas was assembled, or at least altered, by repurposing a snagged comet core as base stock. The frozen bits supply fuel for propulsion lasting ages. The stone parts offer framework and barrier against rays. Flight records indicate atypical steadiness. A body traversing the cosmos faces subtle, yet building influences from sunlight's push, gravity's tugs, and even friction from the sparse, starless gas. Across vast timescales, such effects ought to scatter paths, rendering accurate aiming virtually unattainable without steering fixes. 3 Atlas entered on a course brushing Mars, then grazing the Sun, before heading back to the outer reaches. The accuracy isn't flawless, but it surpasses mere luck. It either stumbled into extraordinary fortune or got directed with purpose. Uncertainty margins allow interpretive flexibility, keeping this in the realm of conjecture over established fact. Still, if we credit the upper bound mass figures, if this is truly measured in billions of tons, the engines needed for subtle shifts grow immense. Think drive mechanisms able to shift peaks, albeit via minute alterations stretched over geological epochs. This prompts the query, what's powering that? Sun-based collectors fail amid the dim, starless leg, where stellar glow fades to nil. Atomic power packs endure for thousands to millions of years at best, barring a stellar core as the fuel depot looming in the distance. Here's where the schedule raises eyebrows. 3 Atlas nears its sun-skimming point, perihelion, when beam strength surges and power potential hits its height. For an interstellar craft built to hoard energy over a million-year haul, you'd aim to arrive in a power-saving sleep mode, then harness sunlight to boot up operations. You'd sync the touchdown for peak solar access with reduced threats from thermal overload and beams. Perihelion matches that scenario precisely. If weight leans toward constructed relic, then behavioral quirks amplify the doubt. A hefty body ought to act foreseeably under familiar influences. When it deviates, when oddities evade explanation via emissions or simulation flaws, we're stuck with tricky options. Our grasp of natural laws might hold gaps that make ordinary things appear man-made, or we're eyeing a genuine creation striving to pass as organic. The data sketches a partial picture. Billions of tons gliding through the void with baffling accuracy, displaying odd material traits, evolving behaviors that stray from predictions. What pushes guesswork toward fixation happens when the tools begin spotting stuff that doesn't belong. Enter Mars. And that's precisely why those leaked photos carry more weight than expected. If 32 Atlas is merely a comet, Mars ought to have detected a comet. If it's an anomaly, Mars should have spotted that anomaly instead. And if Mars did spot something different, yet officials claim it was a comet, the true mystery isn't the nature of 32 Atlas. The real puzzle is what certain parties are trying to conceal from us. Part 3. Mars Close Encounter. What did they actually observe? On October 3, 2025, this was meant to be a standard viewing session. The sort of joint effort that unfolds whenever a noteworthy body traverses the inner solar system. But it has evolved into the epicenter of countless theories about cover-ups by organizations and suppressed realities. From an astronomy standpoint, the Mars pass was unremarkable. 32 Atlas skimmed within about 5 million kilometers of the red planet at its nearest point, close enough for detailed imaging, yet distant enough to eliminate any impact threat. All active orbiters got targeting instructions well in advance and scheduled their viewing slots. Mars Express aimed its advanced stereo camera toward the heavens during the pass periods. The Trace Gas Orbiter gathered spectral data to detect lines indicating molecular makeup through emissions and absorptions. NASA's MEAN mission handled simple light measurements, tracking variations in luminosity. The Mars Reconnaissance Orbiter's high-rise camera, among the sharpest instruments beyond Earth's orbit, was primed to capture any oddities during the event. On the ground, the Perseverance rover tilted its lenses upward at the anticipated times. Overall, around a dozen tools from various probes monitored 32 Atlas amid the Mars rendezvous. Collectively, they offered our finest shot at scrutinizing the intruder up close with existing hardware in position. Afterward, anticipation built for the incoming information. This is when confusion morphs into doubt. Transmissions from deep space follow natural laws, not digital speeds. With Earth and Mars separated by roughly 200 million kilometers right now, signals traveling at light speed require about 11 minutes for a one-way trip. That's a built-in lag no tech can bypass. Factor in the time for compressing data. High-def pictures are massive by satellite metrics, taking hours to send. Include calibration steps too. Unprocessed feeds from probes arrive laced with device quirks, interference, and warping that need fixing before the visuals yield real science. Toss in the syncing among different space entities, each with distinct protocols for sharing findings, and the typical wait from capture to disclosure can extend to days or weeks for intricate analyses. For folks used to instant snaps on phones that go viral right away, this seems like deliberate obstruction. In truth, it's merely the grind of science and red tape proceeding at their usual deliberate rhythm, prioritizing precision over haste. Unless, that is, someone chose to drag it out more. The purported leaked shots surfaced on October 5, 2025, just 2 days post-pass. They're said to hail from Perseverance's raw image repository. The shots depict a faint trail gliding across starry backdrops, aligning with projections for a remote body traversing the view. Yet, within that trail lurk straight, evenly spaced lines, resembling precise calibrations on a ruler that defy chance. NASA's initial rebuttal pinned it on compression glitches, namely JPEG grid lines that can forge false linear features in pics. This issue is genuine enough. The snag with that account? The supposed Perseverance files employ PNG format, which relies on non-destructive compression that avoids such grid distortions. Once folks highlighted this mismatch, the narrative pivoted to faulty pixels, specific sensor spots yielding bogus outputs. Faulty pixels exist, sure, but they usually show as isolated points, not aligned streaks. Aligning several just right to mimic the pattern in those leaks strains credibility, though it can't be ruled out. The next rationale invoked space radiation, energetic cosmic particles slamming into detectors and spawning luminous trails. Such particles do produce trails, no doubt, but in haphazard directions. The uniform parallelism in the leaked exposures would demand several hits at virtually the same slant in one frame, pushing luck but not shattering it. Individually, each rationale holds water. Taken as a set, however, they hint at piecing together excuses to fit the evidence after the fact, instead of forecasting the expected. That's the spark for conspiracy flames. When officials cycle through varying accounts for one event, It appears it's more about hunting for a narrative that endures instead of sticking to the facts. Hobbyists poring over the details pounced on the discrepancies right away. Across various online communities, people broke down the shared clips frame by frame, down to the pixels. A few insisted they'd spotted extra formations past those first straight lines, shapes like polygons that artifacts from data squeezing shouldn't generate. The rest saw zilch, just random fuzz that our brains trick into seeming significant. The argument soon turned factional, dividing folks into groups dead set on spotting signs of man-made design versus those who viewed it as collective hallucination unfolding live. No faction nailed a slam-dunk argument since none could lay hands on the raw, untouched readings from the detectors. All they had were the fuzzy versions bouncing around the web. At the same time, the polished photos from official Mars probes stayed under wraps. Time dragged on. Days turned into a full week. The European Space Agency refreshed its Mars Express records with scans from the start of October. Yet those exact shots from the third depicting the 3I Atlas got left out. Over at NASA, their files had blank spots right in the expected Passover periods, pointing to maybe botched captures, unfinished crunching of numbers, or docs held back for peer-reviewed drops first, or who knows what. The quiet left an empty space that rumors rushed to occupy. How come no pics if it's all standard procedure? The dullest take is that good sightings demand extra time to refine before going public, whereas flops might not merit the airtime. If the aim missed or gear snagged nothing worthwhile, it's no plot, just how ops work. Yet dull takes don't cover the lack of early updates. A quick note saying, sightings went fine. Refinement underway. Data out in a fortnight could puncture most wild theories on the spot. But nope, we get crickets, which stokes the idea that some curveball popped up and insiders are figuring out damage control. The scariest angle isn't a true oddity showing up in Mars shots. It's if various tools picked up identical weirdness on their own, forming a repeat too steady for gear glitches, but too vague to peg as built stuff. Should Mars Express, Trace Gas Orbiter, and Mars Reconnaissance Orbiter all snag alike angular setups in that Passover, forget lens flaws. Now it's legit, flagged by separate detectors. That legit thing might yet be earthly. Ice balls can sprout spurts of venting gas, forming feathery forms. Grit caught in those spurts could mimic streaks in perfect light. Debris swarms from fresh splits might look like twin trails. Plenty of earthbound reasons can fake neat look sans alien angles. But those reasons demand checks against the real feeds. Which loops us to the core snag, getting the feeds. When info hides in agency vaults, even for solid grounds, it smells like hoarding. And these days, the vibe trumps the truth. The track record on how governments handle hints of alien run-ins ain't inspiring. In the Oumuamua saga, it came out later that military surveillance gear tailed the thing nonstop, yielding sharp path logs kept secret for ages. The delayed dump revealed squat out of the ordinary, but the hush-up vibe implied officials at least mulled weird causes. If those same rules kick in for 3I Atlas, we'd stay in the dark till way later, if at all. Locked sightings don't scream cover up, just safeguards for key spy tech. But safeguards and info blocks blur from afar. So here we sit, assorted gear-eyed 3 Atlas in the Mars swoop. Feeds beamed per usual channels. Refinement rolls on schedule. Still, the void of straight-from-the-source visuals has hijacked the tale. The buzz has busted loose already. Imagine if Mars's debut brush with a star-hopping guest wasn't mere science bait, but a sly recon by an entity wise to dodging blatant red flags. Picture those shapes as intentional beacons, or the holdup stemming not from crunch time, but from agency squabbles over spilling beans and public rights? Or maybe it's purely junk, data squeeze glitches, dead spots, ray strikes birthing ghost lines, as the actual 3 Atlas zips by utterly normal, and we're off pursuing ghosts. Specters born from hopeful speculation. The real story likely hides in the yet-to-be-unveiled data, whether mundane or astonishing, based on whatever the cameras truly captured. For now, we remain onlookers at a stellar drama where the veil stays drawn. Each postponement only heightens our suspicion that something's amiss. The issue isn't if Mars detected anything amid the trio of Atlas overflights. We already know Mars spotted something. The real puzzle is whether Mars's observations align with the anticipated outcomes, or if the cosmos has suddenly grown far more intricate, than anybody anticipated. Section 4. Tale of Coma and Peculiar Reactions. Observatories on Earth and in space have been probing 3I/Atlas via spectroscopic analysis. This method breaks down light into its spectral colors to uncover elemental makeup. The discoveries don't fully match the standard profile for a comet, stirring understated unease among astronomers despite assurances from officials that everything's proceeding as usual. In late September 2025, the James Webb Space Telescope directed its infrared gaze at 3I/Atlas, gathering data across several viewing sessions. Initial findings revealed robust carbon dioxide outflows, precisely in line with predictions for solid CO2 turning straight from solid to vapor under the sun's warmth. Yet the proportions were skewed. The CO2 indication was more pronounced than simulations forecasted for an entity at 3I/Atlas's solar distance. Positioned at about 2 AU away, comets generally exhibit water vapor as the primary gas release, with CO2 in a supporting capacity. In this instance, though, CO2 appears to shoulder the main burden, leading the spectral profile in manners implying either atypical makeup or irregular warming effects. One theory points to underground stores of pure CO2 frost that endure nearer the sun than fragile water ice, then erupt forcefully upon sunlight exposure. It's possible 3I/Atlas originated in an exceptionally frigid or carbon-heavy setting, endowing it with traits at the fringes of typical variations. Alternatively, the CO2 might not stem from frost vaporization, but from reactions between outer layers and solar flares or cosmic particles. Such a scenario could account for the amplified signal without invoking rare ingredients, though it would indicate surface processes unlike those in our system's comets. Then comes the hue. Earthbound watchers spotted an oddity in late September 2025. The envelope encircling 3I/Atlas displayed a clear verdant shade, apparent in hobbyist scope photos as a faint jade aura around the core. Verdant comets aren't unprecedented. The shade usually arises from dicarbon, tiny molecular bits formed as sunlight shatters bigger carbon structures in the envelope. However, the emerald from 3I/Atlas feels overly vivid given its luminosity and remoteness. Certain readings also suggested cyanogen, a carbon-nitrogen mix that adds to the green. Detectable cyanogen levels sparked inquiries into nitrogen levels. What's the origin of this nitrogen? Comets hold nitrogen-based substances locked in their frosts, but only in minor quantities. 3I/Atlas seems to release nitrogen-laden particles at elevated rates compared to standard comets. Nitrogen reactions are significant since they link to possible life-building or proto-life pathways. Amino acids demand nitrogen. Nucleotides weave nitrogen into their frameworks. A nitrogen-abundant interloper from beyond our system might transport intricate organics, even the molecular building blocks essential for life, to arise on fitting planets. Or it might transport entities that already crossed from mere chemistry to actual biology, kept in icy suspension throughout the voyage. The truly bizarre reactions emerged in minor metal readings. Various research groups noted lines in the spectra tied to nickel particles in the envelope. Nickel releases have appeared in our system's comets previously. Thus, nickel's existence isn't instantly worrisome. But the quantity felt off. For 3I/Atlas, the nickel mark outshone iron, reversing the norm from universal ratios where iron usually surpasses nickel by over 10 to 1. Experts have floated a few ideas. Perhaps nickel clusters in outer coatings that erode first during initial outbursts. Or iron exists but fails to glow in the same lines, rendering it harder to spot, even if more plentiful. Or 3I/Atlas harbors truly irregular metal ratios that echo birthplace conditions wildly unlike our solar neighborhoods. Nickel-iron mixes underpin the cores of evolved objects. Protoplanets massive enough to liquefy inside, allowing dense metals to descend. Inward movement occurs as these planetary remnants converge. Upon impact, the disruptive collisions fracture them, scattering pieces of the iron-nickel interior that form asteroids laden with metals. A fragment from such a disrupted core, drifting across the void between stars, would exhibit striking metallic traces in its spectrum. Yet these cores lack frozen components. They consist of dense metals and sulfur compounds, devoid of the gaseous ices that drive cometary emissions. To account for Oumuamua-like Atlas displaying elevated metal levels alongside robust gas release, one must envision a composite form, an iron foundation encased in a frozen shell. Such a configuration could arise from a smash-up event, or it might represent a deliberate design, with a metallic skeleton cloaked in icy armor for enduring voyages across stellar distances. The comet's tail introduces further intrigue. As anticipated, Oumuamua-like Atlas exhibits both tail varieties, the widespread, hazy dust stream fanning out in its typical arc. However, in observations from late September, experts spotted subtle irregularities in the ion tail's positioning, with twists or curves that strayed from the ideal opposition to the Sun, defying forecasts based on solar wind patterns. These plasma streams serve as delicate probes of nearby cosmic weather, reacting to shifts in wind velocity, particle concentration, and magnetic influences. The oddities observed could simply reflect Oumuamua-like Atlas interacting with unmonitored solar wind features during those viewing periods. Still, certain scientists pointed out that the tail's shape appeared off, even after factoring in documented wind fluctuations. The curvatures emerged in directions inconsistent with routine dynamic forces, suggesting perhaps uneven expulsion of material from the core instead of mere deflection by the solar breeze. Should Oumuamua-like Atlas be releasing gases asymmetrically, this might account for its path irregularities without needing to posit artificial drives. It remains a straightforward phenomenon, though it implies deeper internal dynamics than the object's surface glow implies, involving heat management and ice conversion hidden from external view. The measured gas emission levels themselves sparked curiosity. For Oumuamua-like Atlas, these rates surpass theoretical models by roughly 20 to 30%, a notable but feasible discrepancy. Elevated emissions might signal a more compact core that warms more effectively than initial size assessments indicate. Alternatively, they could point to an ice makeup rich in highly reactive compounds that vaporize more easily than standard water frost. Viable natural interpretations abound, yet when paired with atypical elemental makeup and hints of path steering, they accumulate into an indirect argument hinting at deviations from typical comet norms. Far from conclusive evidence, but the piling inconsistencies demand ever more elaborate organic rationales to wave them off as mere chance. Then, suggestions of breakup emerged. During early October 2025, multiple monitoring groups detected abrupt fluctuations in Oumuamua-like Atlas's luminosity, short-lived drops in brightness spanning hours to days, followed by recovery to prior levels. Such fades often signal pieces detaching from the main body. Comets routinely splinter, particularly amid intense outbursts when buried ices gasify and generate stress under the crust. If Oumuamua-like Atlas is casting off debris, this aligns perfectly with a comet enduring heat strain. Nevertheless, such breakaways offer insights. A detached segment tumbling free could expose hidden layers, revealing makeups or surfaces contrasting the outer shell. Should spectral analysis of these offshoots detect compositional shifts from the primary form, it would illuminate subsurface stratification. And if a piece displays utterly alien traits, such as dominant metals or unnatural molecular signatures defying geological origins, it would challenge the comet classification entirely. The full compositional profile of Oumuamua-like Atlas stays murky, fueling the unease. It conforms to most anticipated traits, yet strays sufficiently in key aspects to sustain nagging doubts. Carbon dioxide levels stand out as excessive. The greenish hues prove overly vivid. Nickel concentrations exceed norms. Gas outputs run too vigorous. The tail acts peculiarly. Breakup signs may be underway. Unlike 2I/Borisov, the prior verified interstellar comet, which presented an utterly conventional profile, affirming that icy wanderers arise via comparable mechanisms galaxy-wide. Oumuamua-like Atlas withholds such comfort. It appears largely conventional, functions largely conventionally, but harbors deviations potent enough to evoke either exceptional cosmic quirks or an altogether different entity. Now, as it nears perihelion, the peak of solar proximity where underlying processes will intensify wildly, Whatever lurks under that gritty exterior stands poised for exposure. Perihelion promises the decisive unveiling of its essence. Yet prior to that closest approach, an impending solar event looms to challenge the object's durability. A coronal mass ejection from the Sun, that colossal sphere of magnetized plasma weighing billions of tons, is barreling toward a rendezvous with 3 Atlas. The tempest approaches, packed with forces capable of splintering a comet or rousing a slumbering device, depending on whatever lurks unseen in the void. Part 5. Sunstorm Showdown. The sun inhales and occasionally roars. On October 4, 2025, solar monitoring stations spotted a massive coronal mass ejection bursting from active region 3827, a vast grouping of sunspots wheeling over the solar surface. This CME propelled billions of tons of charged plasma across the void between planets at velocities nearing 2,000 kilometers per second, swift enough to span the Sun-Earth gap in roughly 18 hours. Yet Earth dodged the blast on this occasion. 3 Atlas lay directly in its path. Coronal mass ejections rank among the solar system's fiercest phenomena. They unleash bursts of magnetic force that can fling moon-sized quantities of material outward at speeds that would incinerate any human-engineered craft. Upon striking planets, these plasma surges squeeze magnetic shields, spark northern lights, and unleash geomagnetic disruptions potent enough to cripple electrical networks and harm orbiting satellites. Encounters with comets prove far more intense, as these icy wanderers lack shielding magnetic fields, leaving their cores bare to the onslaught. Scientists have observed CMEs clashing with comets in the past. Back in 2007, Comet Encke traversed a potent CME, and telescopes snapped stunning shots of its ion tail severing from the core, ripped free by magnetic pull and abandoned to float, while the comet sprouted a fresh tail in the days that followed. The core endured unscathed, proving that even head-on CME strikes need not obliterate cometary nuclei, although they impose severe strain. But 3 Atlas defies the ordinary comet mold, or so the theories propose. Should the artifact idea hold water, this CME collision offers a live test of sorts. How will the entity react to an abrupt influx of vast energy? Might it shatter like a fragile aggregate unable to bear the pressure? Could it repel the influx, hinting at unforeseen durability? Will it flare up, expelling pent-up gases in a violent release spurred by the incoming particles? Assuming 3 Atlas is wholly organic, the CME could provoke disintegration, splitting the core into fragments on scattering paths, and staging a dazzling yet harmless spectacle as the bits drift apart over time. Such breakups have struck other comets under intense duress. Comet Shoemaker-Levy 9 split into over 20 chunks prior to slamming into Jupiter in 1994. Comet Linear vanished entirely in 2000, morphing from a solid core to a diffuse haze of rubble within days. A breakup event would resolve numerous puzzles. Should 3 Atlas fracture and expose innards mismatched with standard icy rock makeup, the oddity would stand revealed at once. If its pieces match comet expectations precisely, the artifact buzz largely dissipates. Both results bring resolution. A CME imparts a torrent of power in a sharp jolt, laced with electromagnetic waves and particle assaults that might double as ignition and fuel. For an engineered Voyager from afar, primed to stir near a sun, one could envision timing activation for a CME, signaling that stellar output has peaked to sustain functions. The gale serves as an alert. Eons of journey concluding precisely when environs declare arrival. Earthbound solar scopes snapped views of the CME surging forth. Eerie solar loops shining in far ultraviolet rays as charged particles followed magnetic arcs. Orbital tools such as the Solar Dynamics Observatory and the Solar and Heliospheric Observatory delivered non-stop monitoring, following the outburst from initial flare to spaceward spread. Such data enabled experts to chart the CME's course and forecast its crossing with 3 Atlas's orbit. The anticipated collision phase began on October 6 around 1400 UTC, with a margin of plus or minus 6 hours based on the plasma front's true pace. Global observatories synced efforts for unbroken surveillance in that period, scanning 3 Atlas across various light spectra to detect abrupt shifts in luminosity, hue, or form. Then came the pause once more, for signals to beam down, for crunching the numbers, for formal reviews to trail the whirlwind of enthusiast guesses exploding online at warp speed. Certain backyard watchers claimed glimpses of luminosity spikes in 3 Atlas amid the forecast collision span, brief flares enduring for minutes to hours prior to dimming once again to observers tracking the identical object simultaneously detected no anomalies, indicating that the alterations might have fallen beneath the resolution limits of lesser scopes, or the alerts were mere artifacts. Illusory patterns emerging from data noise that didn't exist in reality. As of mid-October 2025, most expert astronomical records stay under wraps, progressing through standard protocols for verification and peer evaluation. Yet initial comments from certain investigative groups hinted at noteworthy phenomena in their captures. Such ambiguous wording could signify everything from dramatic plasma exchanges to subtle shifts in luminosity, or perhaps just unremarkable findings dressed in esoteric terminology. Should the trio of Atlas probes encountered something genuinely peculiar amid the coronal mass ejection strike, perhaps unveiling engineered forms or irregular conduct, the evidence lingers in some repository of sightings. The issue lies in its potential disclosure. Will it surface publicly or fade into secretive scrutiny as official declarations persist in highlighting conventional causes? That solar tempest has since dissipated. The ionized plume that burst forth on October 4th has dispersed throughout the inner heliosphere, enveloping Mercury, Venus, Mars, Earth, and the 3 Atlas entities en route. Any ensuing exchanges have long since transpired. The radio burst has struck, the charged particles have assaulted, the magnetic domains have collided and reformed. Should activation, breakup, or disclosure have been imminent, it has unfolded already. We inhabit the consequences now, anticipating revelations about what those consequences hold. Might the onslaught have outlined a shadow, bearing underlying architecture hidden by the comet's facade as high-energy ions eroded outer coatings? Could it have roused inactive apparatuses, reigniting machinery dormant across eons? Or did it merely strain an ordinary icy body in foreseeable manners, yielding a stunning spectacle of ionized gases that illuminates solar wind dynamics, yet offers no insights into extraterrestrial minds? The probable resolution is the mundane variant. The 3 Atlas endured the CME with slight splintering or superficial alterations. Vapor emissions spiked briefly before settling, and existence resumes largely unchanged. The event failed to shatter the comet or trigger concealed devices, for none exist. Only frozen water, stone, and organic molecules adhering to physical principles in a cosmos ancient beyond measure. Probable, however, does not equate to definite. Within that space between probable and definite thrive all manner of speculative narratives, all aspirations and apprehensions regarding what truly approaches from the interstellar voids. The gale could already be signaling if 3 Atlas pulses with life or lies inert, organic or constructed, hazard or boon. We remain ignorant of the verdict being conveyed, or if those privy to it intend to divulge before the subsequent pivotal juncture. For perihelion looms in late October 2025, the instant of nearest solar proximity where heat surges and thermal pressures climax, determining if 3 Atlas's composition withstands or succumbs. The CME served as a trial run. Perihelion represents the true trial. And should any latent entity await arousal within that gritty core, if the whispers, conjectures, pilfered visuals, and baffling compositions hold any kernel of verity, then Sol itself will soon deliver energy intensities rendering a coronal mass ejection seem tame in retrospect. 3 Atlas plunges toward the inferno, and humanity observes intently for what arises from the blaze. Part 6. Origins from Beyond the Stars. Each celestial body narrates its provenance, inscribed in the script of path and makeup. For 3 Atlas, that chronicle extends deeper into antiquity than any prior comet scrutiny, potentially to an era when the Milky Way was nascent and our star had yet to coalesce from condensing gas nebulae. Orbit reversal stands as a routine method in celestial dynamics. From an item's present locus and speed, invert the dynamical formulas, and compute retroactively to pinpoint prior positions. Within our system, This approach uncovers planetary flybys, solar near misses, or berths in designated zones like the asteroid belt or Kuiper belt. The calculations simplify when solar and perhaps Jovian poles dominate. For extrasolar wanderers, retrocalculation grows vastly intricate. One must factor in Milky Way tidal forces, disruptions from stellar passages amassed over geological timescales, alongside drags from gas clouds and dark matter webs. Inaccuracies multiply over durations until margins eclipse galactic scales, obliterating the path entirely. Nonetheless, scholars press on, employing the finest orbital mappings. Scientists are now utilizing the available measurements to run simulations via galactic dynamics frameworks, aiming to pinpoint the possible origins of 3I Atlas. Initial findings, shared in preprint repositories and pending expert evaluation, point to an astonishing revelation. Rather than emerging from the galactic disk, the broad, flattened spiral where the majority of stars revolve, including our solar system, its path appears to lead back to the thick disk. This is a more rounded layer of ancient stars that move at elevated speeds with erratic directions. The thick disk dates back to the galaxy's early days, filled with stars born before the spiral arms took shape. Should 3I Atlas hail from this thick disk population, the age-related consequences are profound. It could represent material aged 7 to 8 billion years. That's almost double the solar system's span, predating Earth and the Sun, originating when the universe was just about half its present age. This would mark it as the most ancient solid entity humans have examined in detail. A preserved relic from a period typically glimpsed only through remote light from distant galaxies. Yet, a key issue arises. Ice can endure for 8 billion years. By astronomical measures, comets are delicate. These frozen entities steadily vaporize when nearing warm areas or capturing stellar energy while traversing star systems. Even in the presumed chill and shelter of interstellar voids, ice gradually turns to gas under cosmic ray bombardment and the subtle infrared from ambient starlight. Survival estimates for comets indicate durations of hundreds of millions to maybe a billion years within the interstellar environment, far short of multiple billions. For 3I Atlas to retain its ice following an 8 billion-year voyage, one of a few improbable possibilities must apply. Perhaps it lingered mostly within an intensely frigid molecular cloud, insulated against radiation and held near absolute zero, minimizing evaporation to negligible levels. Such clouds span light years and could grant an object eons of profound cooling during transit before it re-enters exposed space. However, molecular clouds themselves persist only tens of millions of years. They coalesce, birth stars, and disperse. To stay iced over, 3I Atlas would have to navigate a series of consecutive clouds, precisely weaving through the galaxy's chilliest, densest zones. Feasible in theory, but akin to defying odds on a cosmic scale, like hitting the jackpot across epochs. Other theories edge toward conjecture. Perhaps 3I Atlas is far from ancient, and the backward trajectory analysis is flawed. Reconstructing orbits across billions of years brims with uncertainties and estimates, inviting mistakes. The thick disk source might stem from flawed simulations, with the body actually hailing from a nearer, fresher locale whose path echoes deep antiquity. Or consider that 3I Atlas may not have traced a spontaneous path. Perhaps it was directed. Galactic density waves provide a plausible avenue. The Milky Way's arms aren't static. They're propagating density waves sweeping the disk, zones of heightened starbirth that linger briefly before shifting. These waves disrupt star paths, generating waves that span hundreds of light years and endure millions of years. Fresh insights from the Gaia spacecraft, charting star locations and speeds with remarkable accuracy, have unveiled these patterns in fine detail. Certain experts suggest that highly evolved societies might harness these waves for guidance, syncing launches with galactic flows that ferry items between systems over vast timescales. It's like stellar voyaging, leveraging gravity's analogs to currents for efficient transit. A probe timed into an optimal wave could span immense gaps with little thrust, relying on the galaxy's mechanics. If 3I Atlas surfed such waves, its emergence wasn't chance. It could have been plotted eons or epochs ago to hit this exact galactic sector at this moment. The accuracy demanded feels unattainable, yet it aligns with endurance. Ample time for fine tweaks via systems enduring geological spans could, in principle, pilot an entity galaxy-wide through subtle, pivotal prods. This ventures deep into hypothesis, but one rooted in established science. Density waves are real. They influence star and interstellar drifts. Intentionally exploiting them for steering remains a tantalizing frontier. It demands technological prowess and foresight that surpass all human accomplishments to date. Yet it doesn't necessitate sorcery, superluminal speeds, or breaches of established physical laws. The timing of its approach introduces yet another element of serendipity. 3I Atlas is nearing our solar system precisely as human society has only just acquired the means to identify and examine extrasolar visitors. Had it come a few decades sooner, we might have missed it entirely until it zipped past perihelion and began its exit. A bit further into the future would hinge on our endurance long enough to erect superior surveillance systems. Right now marks a narrow interval of detection and comprehension. Pure chance. For something born of nature, without question. The cosmos brims with such flukes, given the vast array of chances for them to unfold. Hurl sufficient arrows at random, and a few are bound to strike the center by sheer luck. A single wanderer from beyond drifting in during our era of cosmic enlightenment merely confirms that these interstellar travelers are out there, weaving through star systems from time to time. The pivotal revelation approaches, and amid the deluge of info pouring from global observatories, the proof, pro or con, will clarify if we're isolated in the universe or if we've been approached by an entity older than Earth itself when our planet was in its infancy. Section 7. Concealed Drive Systems. Efforts to detect engineered propulsion in 3I Atlas zero in on a primary indicator. Anomalous speeding up. Any shift in speed not traceable to gravitational tug or routine vapor release from a comet's core warmed by sunlight. Every body traversing the solar system adheres to foreseeable routes shaped by gravity. The sun exerts the dominant pull. Worlds introduce subtle deviations. Even the asteroid belt's collective gravity imparts minor tweaks to paths. Armed with exacting data and robust computing, experts can simulate these pulls and forecast an object's position at any instant with stunning precision. If sightings diverge from forecasts, an unseen force is nudging it beyond what gravity permits. Oumuamua exemplified such a puzzle vividly. During its 2018 outbound journey from the solar system, meticulous monitoring uncovered it pulling away from the sun quicker than orbital mechanics warranted. The surplus boost was modest, just millionths of a meter per second squared, but undeniable and steady over various viewing sessions from assorted scopes. An influence was propelling Oumuamua, sparking prolonged scientific wrangling over its source. The top naturalistic account centered on degassing, where icy coatings on a comet soak up solar warmth, sublimate straight to vapor, and eject into the void. Such expulsion generates momentum via elementary rocketry principles. Escaping particles in one vector recoil the core the other way. Modest venting can yield detectable speed-up cumulatively, particularly for compact, lightweight items like Oumuamua. Still, Oumuamua lacked comet traits. No evident haze, no particle streamer, no clear evidence of ongoing venting, even after skimming near enough to the sun to ignite a typical icy body. Accounting for the noted speed-up via degassing demanded unconventional ideas, largely centered on hydrogen frost, a material so fleeting and shiny that it vaporizes fiercely sans detectable particulate or gaseous traces. A contrasting theory, put forward earnestly by select scientists and more playfully by others, suggested manufactured drive. Perhaps Oumuamua was a solar sail, a gossamer mirror driven by stellar photon barrage, or a derelict vessel spinning aimlessly, leaking fuel or internal gases, or an operational scout employing unfamiliar thrusters undetectable from afar. Each scenario could yield the kind of unaccounted-for speed-up that matched the readings. Experts ultimately favored organic causes, as bold assertions demand ironclad backing. Oumuamua's readings, though odd, fell short of the threshold to summon extraterrestrial engineering. Yet the discussion planted seeds of doubt and set a benchmark. Should a follow-up interstellar arrival display parallel speed-up oddities, The made-by-intelligence idea strengthens via pattern. Now comes 3i Atlas, edging toward perihelion as position logs pile up each day. Teams across the globe scrutinize telescope fixes against orbital simulations, hunting for mismatches. The probe continues, with early findings tentative, though murmurs hint at intriguing signals piercing the clutter. Certain analysts assert the path reveals minor tweaks in the observed deviations in its path align with pure gravitational motion, featuring slight speed shifts that seem purposeful instead of haphazard. These alterations are minuscule, easily lost within the bounds of observational inaccuracies, suggesting they might just be misleading byproducts of flawed data collection rather than genuine physical phenomena. Alternatively, they could indicate the presence of influences on 3i/Atlas beyond mere gravity and routine sublimation. The power demands for even minor path tweaks on such a hefty body are staggering. If 3i/Atlas truly weighs billions of tons, according to the latest mass calculations, shifting its speed by just a few meters per second demands accelerating that full mass in defiance of Newton's third law. This calls for reaction material, fuel expelled one way to drive the object the opposite, or interaction with external factors like solar sails, magnetic influences, or other ambient forces. Sublimation offers an organic boost, converting frozen volatiles into expanding vapors that generate push for 3i/Atlas. The documented sublimation levels might plausibly yield the accelerations that certain experts detect in orbital records. The equations hold up under assumptions of particular venting patterns and yields, yet the targeted nature feels off in certain studies, as though the force direction doesn't match the spots of most intense visible activity. Such discrepancies might signify little. Cometary cores are lumpy forms with intricate terrains, and venting frequently erupts from dark side nozzles or hidden pockets where no obvious dust envelope forms. Lack of clear signs from ground telescopes doesn't rule out robust enough venting to sway the path. We might simply be witnessing the precise thrust profile anticipated from innate mechanisms, awkwardly positioned relative to our line of sight. Or perhaps it's something altogether different. Efforts to spot engine traces zero in on light signatures hunting for charged plumes or odd chemical outputs unlike standard cometary releases. Typical venting yields mostly H2O vapor, CO2, CO, and assorted organics, all thoroughly mapped via spectroscopy. Should 3i/Atlas begin spewing xenon ions, metal vapors, or any human-style ion-drive fuels, that would scream artificial tech right away. To date, nothing like that has surfaced in public data. The light profiles reveal CO2, C2, CN, and nickel traces, all fitting quirky, yet plausible natural comet reactions. If engines are at work, they either rely on unfamiliar fuels or operate so discreetly that their marks merge with ambient venting. Blended concepts bridge the gap between wholly organic and fully engineered. Picture a cometary core born eons ago through natural means, later snagged and upgraded by an advanced society. They retain the frosty shell for shielding and stealth, while installing core engines, guides, and steering tech to channel gases for precise adjustments. The surface stays authentic looking. The overall makeup scans as cometary, yet the motion strays just enough from unadulterated natural dynamics. From a design standpoint, this fused strategy is logical. Crafting a vessel anew demands vast supplies and setups. Hijacking a ready-made comet and adding basic steering taps local resources and offers superior safeguarding for vital cargo on cosmic voyages. The comet facade serves not as trickery, but smart repurposing of ready assets for tech goals. Unmasking such a fusion from afar would prove extraordinarily tough. The weight stems from native ices and stones, so bulk readings overlook minor embedded gear. Venting stays predominantly organic, so scans appear normal even with targeted fractions. The path displays boosts matching sublimation, and even guided venting might evade detection without ultra-precise tracking over repeated sightings to flag intentional shifts. Certain researchers assert they discern those very clues in 3i/Atlas's path logs. They highlight links between luminosity spikes implying burst vents and following speed tweaks that appear fine-tuned for path stability. These ties are faint, potentially chance-based, but evident upon scrutiny. Their reliability teeters, with p-values dancing near the cutoff for solid findings, hinging on the analytical tools one favors. Science insists on restraint amid such margins. Initial findings often reveal quirks in the data that fade away once improved instruments and more precise evaluations are applied. Apparent signals frequently prove to be mere fluctuations, instrumental biases, or byproducts of handling the information. Announcing discoveries of engineered thrust relying on flimsy probabilistic indicators risks professional repercussions if later studies cannot validate them. Yet, excessive prudence has its downsides too. Should authentic signs of propulsion be present but concealed just below detection thresholds, holding out for irrefutable confirmation could squander fleeting chances to collect additional details while the entity is still within view. Once consensus forms that the indication is legitimate, 3I/Atlas could have already traversed perihelion and started its outbound journey to the stars, becoming too faint and remote for in-depth scrutiny. This underscores the importance of monitoring after perihelion. If 3I/Atlas employs any form of drive, its effects would emerge most evidently post-perihelion, as solar warmth diminishes and inherent sublimation slows. Persistent speeding up during that interval, amid waning thermal influences, would defy straightforward natural interpretations. That would serve as the definitive indicator. Alterations in path that endure when they ought not, suggesting deliberate maneuvering over mere reactions to stellar heat. The anticipation persists. Perihelion arrives in late October 2025, followed by extended periods of observation as 3I/Atlas moves away from the Sun and ventures deeper into the outer realms of our system. Should odd accelerations manifest then, the case for artificial origins gains considerable weight. If the motion halts right as sublimation would wind down, conventional accounts hold sway. Part 8. Within the core. Probing what hides under the powdery surface of 3I/Atlas ventures into the realm of bold conjecture, as we lack any concrete clues regarding its makeup and are unlikely to obtain them barring a breakup or some probing scan that pierces the shell. Ideas of a cavernous interior have persisted since early musings on Oumuamua's peculiar traits. The notion is simple. Crafting an interstellar craft to transport cargo over cosmic expanses demands efficiency, not density. A dense form squanders material on framework offering little utility. Rather, excavate the inside to form empty chambers for gear, sensors, energy sources, or perhaps shielded organic cargo buffered against rays and strikes by the enclosing hull. Such a configuration could account for puzzling observations. Reduced overall density compared to compact stone or frozen masses, aligning with volume assessments that suggest unexpectedly substantial weight. Remarkable durability against heat and strain, enduring forces that would shatter a fragile aggregate of debris. Odd vibrational or echoing behaviors, should potent radar pulses ever echo back from within, though no such reports have surfaced in public forums. A recurring idea in these theoretical exchanges is the Dyson fragment. Not an entire Dyson swarm encircling a star to harness its full output, but a detached sliver. A modest remnant of sophisticated megascale engineering adrift through the void. Freeman Dyson's original vision involved enveloping suns with vast collectors to exploit stellar energy. Detached portions or shattered bits propelled into the galaxy would largely consist of hollow enclosures, sleek casings prioritizing expanse over heft. And such fragments slicing through our solar domain would appear bizarre, excessively slender, and consistent to pass as organic. Likely overly shiny without intentional dusting for disguise. 3I/Atlas doesn't align neatly with this image, yet if one imagined encasing a shard in layers of frost and grit gathered from navigating nebular regions, it could mimic a comet perfectly, until heat or rupture unveils the constructed heart. Speculation on unconventional substances centers on carbon-based nanomaterials, graphene layers, fullerene spheres, the array of marvels unearthed in labs, but not yet scaled to vast constructs. These boast extraordinary durability per unit mass, heat handling capabilities to cope with drastic shifts, and resilience to corrosion that might endure eons if shielded from rust and wear. Might they withstand 8 billion years? Possibly. Carbon forms resist breakdown chemically, and amid the frigid emptiness between stars, Decay stems mostly from high-energy particles and rare dust encounters. Built with ample layering and backups, where builds gradually without inevitably undermining the whole. It's akin to plating that erodes bit by bit. The exterior layer of the object shields its core contents all the way to the final target. Thermal tolerance plays a vital role as it passes through perihelion. In typical comets, the inherent ices split and shatter under severe temperature differences. The outer layer warms from solar radiation even as the inside stays icy, generating physical strains that surpass the material's limits. Should 3I Atlas endure perihelion without breaking apart? Despite facing heat levels that would shatter ordinary comets, it implies either an atypical makeup or engineered strengthening. Empty interiors would offer clear space for any cargo the probe could transport. Scientific gear can be compactly housed in purpose-built spaces. Energy sources, be they nuclear or unconventional, slot into protected areas hidden from outside view. If biological elements form part of the payload, they could reside in environmentally regulated sections that hold steady conditions no matter the outer environment. This notion of internal voids in 3I Atlas ties into the ongoing module and seed theories that pop up in hypothetical talks. If the entity isn't a monolithic whole, but instead a transport vessel holding separate modules, those units require compartments for transit. Inner holds, ejection ports, and release systems all demand room that dense natural comets lack. Yet, the issue with theories of cavernous forms remains. Observations so far can't verify them. Gravitational scans could spot uneven densities if an orbiter circled 3I Atlas, gauging its pull on the satellite to uncover mass inconsistencies. But no such orbiter exists, nor is one feasible soon. Radar signals could probe beneath the surface to find cavities, given sufficiently strong emitters and detectors in the right spots. However, Earth-based radar for planetary objects struggles with the reach and precision needed at 3 Atlas's present range. Breakup offers the clearest chance to expose the inner makeup. Should stresses at perihelion tear 3 Atlas asunder, the drifting pieces from the core body might display cutaway views of the inside. Analysis of newly bared surfaces via spectroscopy could identify substances obscured by the gritty outer coat. Close-up photos might reveal shapes or features that don't match the haphazard breaks seen in frozen natural bodies. There are natural reasons for porous or airy builds. Comets assembled from rubble, loose clusters of minor fragments bound only by their own pull, can reach porosities near 50%, so roughly half the space consists of gaps amid the bits. This isn't engineered emptiness like deliberate hollows, merely haphazard stacking of odd shapes, yet it yields comparable drops in overall density. Such rubble piles arise from smash-ups followed by reassembly under gravity. Original bodies get demolished in collisions where debris doesn't fully escape, letting pieces reassemble into flimsy heaps. This mechanism is established for asteroids in our solar system and probably holds for comets too. An interstellar rubble pile wouldn't be odd. It's simply a comet that withstood its birthplace and got flung onto a hyperbolic path. Still, these piles are delicate. They hold up only under mild treatment, steering clear of strong pulls or disruptive tides that could scatter the components. 3 Atlas has faced intense heat buildup nearing perihelion and withstood a coronal mass ejection that ought to have disrupted any scattered pile. If it stays whole amid such trials, then it's either not rubble-bound or features extra binding beyond simple attraction. The blended concept of a native framework bolstered by synthetic casing keeps surfacing since it addresses several issues at once. Begin with a standard comet core for bulk and cosmic ray protection. Incorporate inner bracing, maybe crystals cultivated on-site or targeted braces to manage pressures. Encase or sheath in man-made layers that safeguard without altering the comet-like look. The outcome is largely organic yet upgraded for better endurance and utility. This echoes how humans design probes for harsh realms. We avoid fabricating from nothing when raw stuff serves. Shielding against radiation employs water or plastic-like substances found in nature, but shaped deliberately. Frames rely on metals like aluminum or titanium, common elements refined for use. An advanced society could scale this up, treating comet cores as base stock and inserting just enough tech enhancements as required. The true puzzle concerning the internal composition of this enigmatic body goes beyond mere hollowness, reinforcement, or artificial design. It hinges on whether that core aligns with ongoing operations or long-forgotten objectives, whether we're dealing with a functioning scout still carrying out its task or a relic that traversed the stars successfully yet fell short of its ultimate goal. Should fissures emerge as it swings closest to the sun, and if fortune smiles on us with a glimpse inside, the inner makeup could instantly clarify the situation. Operational setups appear structured, precise, and purposeful. Breakdowns manifest as eroded, broken, and inert. Organic formations seem chaotic, irregular, and rock-like. The differences ought to stand out clearly upon direct inspection. For now, though, the core stays an ideal spot for conjecture. It might house machinery, life forms, void, or dense frozen material, and existing data fails to differentiate among these possibilities. That's equally aggravating for researchers craving clarity and ideal for anyone who favors lingering mysteries. We're hurtling toward a pivotal juncture where certain enigmas could unravel. As heat buildup and intense sunlight test the limits of Oumuamua, it will either hold together or shatter into telling fragments. The timer to perihelion ticks on, counting down the days until peak thermal strain hits. No matter what lies under that grimy surface, the sun's glare is set to pry it open as best it can. And should that unveiling expose signs of intelligent crafting, our species confronts an urgent dilemma that's lingered in theory alone. How should we respond upon confirming we're not solitary in the cosmos? Part N, Plots and Hush-Hush. The divide between what's shared openly and what's locked in secret compartments breeds fertile soil for wild theories. Oumuamua has sparked plenty in the days following the supposed Mars close-up views. The buzz-sweeping online platform centers on one core charge. NASA is intentionally holding back images from the Mars encounter because they depict something the masses aren't ready for. Proponents argue that sharp shots from the Mars Reconnaissance Orbiter or similar tools snagged undeniable proof of engineered features during the pass. Proof so stark that everyday rationales fall flat. Now, officials are allegedly plotting a rollout strategy to avert widespread alarm. The evolving excuses in press releases, from pinning it on JPEG glitches to shifting blame to faulty pixels and space radiation, raise red flags because they feel like after-the-fact patches, not solid assessments. True image distortions would be instantly recognizable to the experts handling these cameras routinely, who spot every type of glitch inside out. The constant tweaks in rationale imply either uncertainty in their conclusions or a hunt for believable narratives that sidestep the real findings. Gaps in mission records happen often enough. Not all attempts pan out due to tracking slips, alignment issues, sync problems, or gear malfunctions, yielding nothing salvageable. In such cases, those files often skip public upload altogether, leaving voids that seem shady but stem from everyday logistics. Still, openness is key to fostering confidence. When ops glitch, quick reports on the mishap and its cause stop rumors from proliferating in the void of info. The quiet on Mars data stokes doubts exactly by inviting flights of fancy. A straightforward update: Mars Express lost lock from an aiming fault. No valid imagery acquired. Would quash chatter on that batch right away. Claims of info control and crisis aversion draw from past events that are fuzzier than fans or skeptics admit. Do agencies stash away details on possible alien encounters? In a broad way, yes. Defense and spy outfits scan the heavens and seal away tech specs on their detectors, no matter the detections, to shield tactics from foes and mask surveillance prowess. But quashing specifics tied to extraterrestrial tech? Hard proof for that is scant or absent, mainly relying on unbacked claims from purported insiders lacking evidence. All big UFO or UAP cases released to the public have boiled down to banal causes: camera flaws, secret flight trials, weather oddities, or plane mix-ups. Investigating everyday items in extraordinary scenarios often calls for discretion, especially if verification of a probe takes place, at least at the outset. The ramifications of verifying an engineered interstellar visitor are profound, influencing fields from scientific knowledge to philosophical outlooks and even global security dynamics. Proper revelation would demand collaboration among space authorities, national leaders, research bodies, and likely defense and espionage groups prior to any widespread declarations. Such alignment demands effort, spanning days or even weeks, at the very least, for an event of this magnitude. The UMA-MUA incident, involving the Defense Department's secret surveillance, offers a revealing historical parallel. It came to light months following the initial detection that armed forces orbital monitoring networks had followed Oumuamua non-stop, producing ultra-accurate path information that outstripped any details from public stargazing efforts. This information stayed under wraps amid early discussions on Oumuamua's origins, with declassification and sharing occurring only after the entity had departed the solar system's core regions. What prompted the restriction of path details for a standard comet? The stated rationale revolves around safeguarding detection methods, avoiding alerting rivals to the exact acuity of American setups in tracing tiny bodies across vast cosmic spans. From a tactical standpoint, that logic holds water. Orbital junk, orbiting craft, prospective armaments, all necessitate exact monitoring. Disclosing your surveillance sharpness exposes your protective and aggressive potentials. Yet the schedule of unclassifying and distributing the info, right after public fascination crested, hints at alternative motives. Perhaps officials aim to observe how amateur assessments unfolded before introducing restricted details that could steer the inquiry elsewhere. Perhaps they conducted independent reviews, benchmarking their findings against public insights. Perhaps they were merely exercising prudence with outputs from vital apparatuses, adhering to routine protocols irrespective of the subject. Or perhaps the detailed surveillance captured elements overlooked by public scopes, details grave enough to warrant hush, while they deciphered its significance. A similar dynamic might be unfolding with 3 Atlas. Defense orbital watch networks are undoubtedly monitoring this body, likely with sharper focus than amateur scopes manage. That surveillance info is likely sealed under the identical reasoning that hid MUA details. And should that sealed surveillance reveal path irregularities more clearly than public readings, the public stays in the dark until officials deem it appropriate to reveal. Doubts intensify when voids appear where facts ought to reside. Almost 2 weeks have passed since the Mars close pass. During this period, no refined official visuals have surfaced, no research articles filed with publications, no media bulletins detailing outcomes. This gap stands out starkly because the event merits scientific attention, whether 3 Atlas proves natural or crafted. Documenting an interstellar body's near miss, even routinely, warrants dissemination. The skeptical viewpoint implies that records are being scrubbed prior to online release, with compelling shots excised or altered to erase odd traits before the collection becomes accessible. In today's tech landscape, such edits are simple using advanced photo tools. Erase select glaring dots, blend over sharp designs, tweak brightness to obscure subtle forms, and an odd snapshot becomes ordinary sans clear signs of tampering. The hopeful angle merely concedes that handling intricate cosmic data demands patience, and we're still inside standard processing windows. No malice at play, just experts proceeding meticulously before unveiling findings open to rigorous examination. The visuals will emerge in due course, likely depicting a typical icy wanderer where supposed oddities turn out to match official descriptions. Glitches and static, not genuine clues. Still, hope hinges on faith, and faith wanes with each passing day of baffling quiet. The online era has shaped demands for instant data availability, turning even justifiable waits into sources of mistrust. We're used to rapid picture shares, live feeds, swift curiosity, quenching via web searches, and online networks. When cosmic organizations stick to classic schedules in weeks, not hours, it comes across as intentional blockage, though it's often standard practice. Beneath every wild theory lies a straightforward query. If 3 Atlas truly bears signs of engineered beginnings, if NASA, ESA, or a defense intel unit holds proof of extraterrestrial tech in our sites, would they disclose it? And should they opt against disclosure, at least not right away ultimately, could such a choice hold water? Proponents of measured revelation stress the need to avoid widespread alarm, preserve societal order, and buy time for thorough evaluation prior to dropping world-shaking revelations. Opponents of withholding information highlight core democratic values, the public's entitlement to transparency, and the sheer futility of guarding such revelations in today's hyper-connected world of instant sharing and amateur astronomy. No side stands out as clearly misguided. Each captures valid worries about managing paradigm-shifting revelations for humankind, and this clash fosters an ideal breeding ground for wild conspiracies to flourish, plugging informational voids with guesses that remain unrefutable until the core evidence surfaces. We're stuck in that limbo at the moment, hanging on for the eventual unveiling of details that will either validate or dismantle the rumors swirling ever since those initial blurry photos hit the web. That anticipation might wrap up soon with a deluge of refined visuals revealing nothing extraordinary. It might drag on for days amid red tape and internal deliberations. Or it might linger forever if the findings truly harbor elements that officials deem too disruptive for general release. The timer ticks onward. Full stop. Without authoritative clarifications, grassroots conjecture floods every digital outlet with ideas from reasonable to outlandish, all vying for eyeballs in a media landscape where reality and make-believe merge into a hazy blur. Part 10. Origins and Clusters. The idea that 3i Atlas could be hauling deployable cargo flips the risk evaluation from mere watching to deliberate meddling. A profound change in the gravity we assign to this entity's intrusion into our cosmic neighborhood. Seeding hypotheses draw from foundational biology and escalate to galaxy-spanning tech. Earth's teeming variety of organisms, for all its splendor, relies on shared biochemical foundations, pointing to a unified genesis. DNA employs the identical coding scheme across every kingdom. Proteins shape up with the standard set of 20 building blocks. Energy processes in cells track comparable routes. Such consistency implies that igniting life could be the toughest hurdle, whereas branching out afterward unfolds naturally over eons amid shifting habitats. If sparking existence truly demands rare setups and improbable chemical flukes, then an advanced society that cracked the code for generating or nurturing biology might opt to distribute it intentionally. Not purely from benevolence, perhaps, but driven by an urge to cultivate the universe, sowing potential in promising soils and observing the outcomes. A star-spanning seed vessel would pack genetic essentials or autonomous nanoreplicators, shielded for enduring voyages and primed to kick off upon sensing a viable setting. As 3i Atlas nears a sun-like G-class star, slipping into a system with telltale life signs, oxygen-laden air on the third world, it could read those cues as go time for release. The cargo stirs to life, maybe harnessing the sun's closest approach for energy, and unleashes protocols crafted eons back by creators now vanished or transcended. The dispersal method might mimic a comet's breakup. Heat from the sun's grays fractures the core, freeing seed-laden chunks that peel away from the bulk, each veering on paths shaped by vapor jets and launch momentum. Certain pieces slam into worlds, others settle into lasting paths, while some break free from the system's pull. It's a scattershot approach, crude yet resilient, needing no fancy navigation, only smart upfront engineering. Alternatively, targeted drops could employ engines to guide split-off segments to chosen spots post-attach. Mars drew focus in the October pass, likely a scouting run to gauge seeding potential. Earth enters the picture shortly, based on trajectory alignments. The Moon, Venus, or even Jovian satellites and belt rocks could get doses if the plan calls for broad system broadcast over pinpoint strikes. What might those seeds hold? The hopeful take features raw organics, amino acids, nucleotide bits, fatty layers, the raw ingredients for vitality, minus any ready-made organisms. Dumped on barren globes, they could spark native biogenesis, accelerating organic development that might otherwise crawl over geological timescales from zero. It's engineered panspermia, steered instead of haphazard, smart orchestration free of constant oversight. The balance takes ships full-fledged reproducers, artificial protocells, or protein contraptions able to multiply and adapt. They'd lack smarts, merely atomic engines set to. They might adhere to preset directives, yet under typical criteria, they'd qualify as living entities. When introduced to fitting habitats, these forms would proliferate, branch out, and over vast timescales, develop into intricate structures potentially leading to sentience. The originating society wouldn't dictate the results. It would merely kick off the mechanism and allow evolutionary forces to steer progress. Our planet already boasts a thriving biosphere, which adds layers of difficulty to any such seeding effort. Adding foreign life forms to an existing ecological web sparks rivalry, hunting dynamics, and risks of systemic breakdown if the imports aren't balanced by inherent limits on their spread. Earth's record with non-native species illustrates the havoc that thriving outsiders can wreak on local variety. A newcomer from a distant stellar origin, shaped by alien evolutionary forces and perhaps relying on unfamiliar chemical foundations, could unleash utter chaos. Alternatively, it might prove utterly futile, failing to operate in our world's chemistry, swiftly eliminated by factors like oxygen damage, thermal extremes, or countless other norms that terrestrial life endures effortlessly. Sending biology across the stars presents a monumental hurdle, demanding resilience against transit rigors and integration into realms that could clash with its core needs. The phased incursion framework heightens the peril significantly by envisioning not mere seeds, but orchestrated assaults via engineered or organic deployments aimed at seizing planetary domains. Here, 3-2 Atlas functions not as an isolated body, but as a central carrier, a colossal transport hauling various components that detach amid closest solar approach to embark on distinct operations. Initial stage focuses on scouting, mapping the star system for assets, dangers, and prime sites. The Mars encounter fulfills this role. Near flyby enables in-depth scans of worldly traits, air makeup, terrain details, and even signs of tech hinting at sapient presence. Should Mars reveal signs of society, the dispatched units could vary from those sent to a barren world. Subsequent stage launches per initial findings. Components break away from the core, each loaded with specialized gear for varied aims. Certain ones could zero in on mineral-laden asteroids, deploying automated miners and factories via duplicating tech. Others might venture to distant icy satellites, carving out fortified outposts in hidden watery depths shielded from cosmic rays. Some could target Earth directly, either to engage any spotted civilization or to eliminate rivals prior to asserting supremacy. Final stage centers on unification and growth, with units linking up to erect lasting setups. Data links form, enabling dispersed elements to exchange intel and synchronize moves. Production surges, harnessing on-site resources to forge extra units surpassing the carrier's initial stock. Numbers swell, be it through organism breeding or robotic duplication, until the aggressors muster enough strength to fulfill their embedded goals. This setup echoes pulp sci-fi because it stems from speculative warfare tactics transposed to cosmic scales, with scant ties to real data on 3-2 Atlas. Still, it's crucial to ponder, given the dire fallout of overlooking it. If there's the slightest chance that 3-2 Atlas signals a deliberate incursion over an inert wanderer, the right countermeasures veer sharply from mere observational studies. Ideas of biological cargo stir parallel, yet grave issues. Should 3-2 Atlas bear living cargo, from basic compounds to advanced beings, any breach into Earth's life web could yield permanent damage. Safeguards for Mars return materials, protocols to isolate unknowns pending hazard checks, apply to managed hauls and secure vessels, not meteor shards slicing through skies and dispersing fragments over vast lands. If 3-2 Atlas harbors truly extraterrestrial life with novel coding, odd molecular setups, or solvents unlike water, the incursion might fizzle out on its own. The foreign life just withers in our setting upon contact, offering no sustained danger. This hopeful view sees chemical mismatches as a shield, sparing both ecosystems from cross-contamination. The true hazard might not lie in 3-2 Atlas proper, so bulky, obvious, and monitored by global scopes. The genuine risk stems from its hidden freight and dispersals. Tiny fragments that disperse into the void even in the worst-case scenarios. It's prudent to assume the main vessel could release smaller units to carry out separate objectives as we concentrate on the primary craft. Once we detect that any dispersal has taken place, those scattered components could already have embedded themselves too deeply for us to track or eliminate effectively. This kind of dire foresight is standard procedure in vigilant security operations, applied irrespective of the odds. Still, the odds strongly favor 3I Atlas being nothing more than an ordinary comet. That streak across Mars was merely an imaging glitch, with no incursion or planting underway. Yet the fallout from misjudging this could be devastating, so even remote chances warrant thorough scrutiny and readiness. The closest approach to the Sun looms just days off. Should any payload separation occur, it'll unfold imminently. And if the event passes without incident, if 3I Atlas swings through perihelion and heads outward, displaying no fragmentation or odd maneuvers, the buzz dies down, and we resume standard protocols until another cosmic wanderer sparks the routine all over again. But something about this instance stands out. The buildup of irregularities, the precise timing of sightings, the conspicuous hush from authorities, they all hint at deeper machinations beyond mere research. Perhaps it's merely happenstance and flawed readings. Or perhaps we're witnessing the initial steps of a confrontation that will shape humanity's destiny more lastingly than any chapter in our annals. Time is running short. Those subunits may have already been dispatched, leaving us clueless about the follow-up. Part 11. Cosmic Currents and Trajectory Guidance. The Milky Way thrives in constant motion. It's a vibrant network of streaming material and forces, where unseen flows propel entities over vast cosmic expanses. Much like sea streams transport vessels over global waters, fresh insights from the Gaia mission have unveiled these streams with remarkable clarity. And they spark compelling theories on how 3I Atlas reached our vicinity. Gaia has charted more than 1 billion stars with accuracy that uncovers not only their positions, but their velocities too. When compiled into broad galactic charts, trends surface. Celestial bodies don't circle the core in flawless rings. Instead, they exhibit undulating distortions, surges rippling through the galaxy's structure over spans of thousands of light years. These density waves signify zones of fleeting matter buildup before the pattern shifts ahead, akin to persistent bottlenecks amid flowing vehicles. New stars ignite preferentially in these waves, where nebulae squeeze to ignition thresholds. The galaxy's spiral branches outline these waves, highlighting denser gatherings of stars and clouds than the norm. Yet these waves influence far beyond stars and gases. They disrupt all in their wake, including shadowy comets gliding between systems. A body passing through such a wave faces amplified pulls that subtly shift its direction. Across eons and repeated passages, these nudges build up to major deviations, channeling paths in foreseeable ways, all without engines. Imagine it as cosmic wave riding. Propel an item with a starting push that aligns with forthcoming waves at ideal points, and the waves themselves steer it toward the goal. The guidance is subtle yet unrelenting, demanding no resources beyond initial setup and exact launch timing. For journeys spanning millions of years, this method is brilliantly efficient, harnessing the galaxy's forces for propulsion while internal tech stays dormant. Might 3I Atlas be harnessing such flows? Path analysis points to potential harmony with established wave formations, despite lingering ambiguities. If it hails from the dense disk layer per certain simulations, it could have crossed several waves en route, each brush tweaking its route incrementally, until the collective tweaks directed it our way. The ramifications run deep. Should sophisticated societies master these galactic flows to serve as travel guides, then crossing the stars grows practical. No vast power reserves required for near-light boosts, merely sufficient thrust to access the right wave paths. Then let the cosmos ferry your explorer home. This aligns with concepts of scheduled entry slots. Such waves cycle on fixed rhythms, opening and closing guidance corridors periodically. 3I Atlas showing up now, in the dawn of the 21st century as our tech finally spots such intruders, might signal one such slot. Not chance, but design. A course charted eons or epochs passed to cross our realm at a moment dictated by the galaxy's ancient orbits. The resemblance to Polynesian navigating isn't just a figure of speech. Ancient Polynesians traversed vast expanses of the Pacific Ocean without any tools, relying on swells and faint natural signals to locate minuscule atolls amid endless seas. They harmonized with the sea, interpreting flows to direct their vessels with precision. On a cosmic level, interstellar guidance might function analogously, but across mind-boggling distances, by detecting gravitational ripples to maneuver amid stellar clusters. Should this concept of surfing cosmic waves hold true, it prompts profound debates on intention versus coincidence. Does the advent of 3I Atlas stem from purposeful steering via known cosmic forces? Or was it merely a fortuitous path that synced with these flows by sheer luck? The difference carries huge weight. Intentional entry points to purposeful design and foresight, regardless of whether the architects have vanished eons ago. Random entry suggests only haphazard drift within an ordered cosmos. Present data fails to resolve these possibilities. Without evident path alterations as 3I Atlas nears, the issue of directed travel stays unresolved. Yet if harnessing such waves is feasible, if these density fluctuations truly offer usable frameworks for streamlined travel between stars, the cosmos emerges as far more intertwined than we imagined. Far from a barren expanse, traversable solely by chance, it forms a web of routes binding stellar realms via enduring formations that span galactic epochs. Societies leveraging these channels might dispatch explorers galaxy-wide, not via raw thrust, but by cleverly tapping inherent motions. This hints that the Milky Way could already harbor such emissaries, trailing wave contours. Countless or myriad artifacts might weave between stars on paths optimized for broad reach with minimal fuel use. Many glide past barren zones undetected. Now and then, one reaches a spot under observation, yielding instances like Oumuamua and 3I Atlas. Fleeting peaks into the steady stream of interstellar commerce. Humanity's perch in the galaxy is utterly ordinary, roughly midway from the core along the Orion Spur, a modest branch amid grand spirals. From a travel standpoint, our spot holds no distinction, except perhaps that its ordinariness is the very appeal. Bustling starbirth zones and spiral limbs teem with turmoil, packed with exploding stars and hazardous emissions. Calmer spaces between arms, such as ours, could be ideal for their steadiness, boosting chances for delicate life forms to thrive. A dispersal effort aimed at habitable worlds might prioritize these serene sectors. Under this view, the cosmos itself turns into a cultivated orchard. Gravitational surges ferrying organic or engineered payloads across systems, spreading triumphs of evolved societies over cosmic timescales. Life on Earth could trace back to one such delivery. Still, confirming or refuting extraterrestrial origins via panspermia stays nearly unattainable absent blatant signs of engineered traits in our DNA. If 3I Atlas belongs to this conveyance system, if it's gliding on waves while bearing payloads, its presence here signals no unique focus on our planet. We're simply a waypoint on its itinerary, one stop among countless potentials. This realization feels both reassuring and disquieting. Reassuring, as it rules out any aimed peril. Disquieting, since it underscores our lack of uniqueness. Just another promising site in a primordial dispersal scheme we had no say in joining. The notion of vast-scale cosmic routing also clarifies puzzles about chronology. If wave paths dictate schedules over deliberate beacons, then the timing of arrivals hinges on celestial orbits rather than alignment with societal development. 3I Atlas shows up precisely when the surges deliver it, not due to any surveillance of Earth. That said, this presumes no on-site refinements. Should the device lie inactive for much of its voyage but rouse near target stars, it could perform last-minute course fine-tunings to perfect its entry angle for the task at hand. The swing by Mars might illustrate that, employing gravity slingshots or minor boosts to zero in on Earth beyond what the wave path offered alone. Should these ideas pan out, we're witnessing stellar wayfaring unfold live. 3 Atlas cresting galactic swells en route to a target set billions of years prior, presently fine-tuning its descent as we humans rush to decipher the spectacle. This transcends mere solitude in the void. If wave-surfing artifacts roam, if the galaxy weaves guidance grids linking stars through harnessable forces, then minds have been disseminating across the heavens for ages. We stumble in as tardy participants to a gathering that kicked off with the cosmos's dawn, only now crafting tools to realize we're far from the initial arrivals. Whether visitors arrive with warmth, neutrality, or aggression is the key enigma we can't yet unravel. Those very currents that transport life's potential might also deliver armaments, monitoring devices, or mere research tools. Without further insights from 3 Atlas into its essence and objectives, we're stuck piecing together implications from trends and hypotheticals. As perihelion draws near, it could usher in enlightenment or letdown, hinging on the cosmos's whims. The currents persist in their endless cycles, unconcerned by whether observers detect the trails they forge amid the void separating stars. Part 12. Enceladus Organics. POW. Amid the spotlight on 3 Atlas and its enigmas, a subtler find from September 2025 is steadily altering our views on life's possible habitats and the ramifications for cosmic dispersal concepts. Saturn's satellite Enceladus, renowned for its hidden ocean beneath the surface, has now provided spectral proof of intricate organic compounds far more advanced than earlier findings. This breakthrough stemmed from examining ejecta from the Moon's south polar jets, frozen bits laced with ocean fluids that broke free from the satellite's feeble pull and dispersed across Saturn's earring. The Cassini probe gathered ample samples of these jets over various passes from 2004 to 2017, spotting basic organics, minerals, and signs of seafloor vents driven by heat. Fresh scrutiny, employing refined spectral methods and improved standards, has uncovered precursors to amino acids in the stored Cassini records, elaborate carbon-nitrogen structures that form the foundations for proteins. These represent not full amino acids, but entities just a single or double reaction removed, implying that the Moon's aquatic reactions foster settings ripe for biochemically vital formations to arise on their own. This validates long-held astrobiology theories. Watery realms across our solar system, and likely the entire cosmos, offer niches where the raw materials for life develop without intervention. Think Europa around Jupiter, Titan near Saturn, Ganymede and Callisto, plus perhaps a handful of other satellites, each probably hiding subsurface seas with parallel reactions. Such aquatic domains surpass rocky worlds with exposed liquids in numbers, positioning them as prime candidates for habitability across the universe. Should life spark readily in these ocean havens, and if they're widespread, then biology itself proliferates accordingly. Not necessarily sentient forms, as evolving from basic reactions to intricate minds demands further improbable leaps, but at minimum, simple organisms or analogs. The cosmos teems with such vitality, much of it concealed under frozen shells, beyond the gaze of ground-based scopes, poised for revelation by any society capable of boring through kilometers of frost or capturing spewed vapors. This bolsters the feasibility of life-dispersing missions immensely. For an advanced society mastering life's genesis or hastening it, ocean moons emerge as ideal destinations for sowing. Abundant, enduring, rich in fluid and reactive power, shielded from harmful surface rays that could harm nascent biology. Introducing biopackets via collisions or targeted insertions into these worlds aligns perfectly with optimizing colonization outcomes. In this lens, Earth loses its singularity, emerging as merely one instance amid countless viable niches strewn galaxy-wide. A 3 Atlas entrant into a system brimming with ocean satellites could prioritize those bodies over zeroing in solely on our planet. Mars drew notice on its overflight, likely due to echoes of its watery history etched in its rocks. Europa rises as a top contender. Enceladus could even get a delivery if the craft's path permits a Saturn skim. The Moon illustrates seeding mechanics in action. Its vents already prove that deep-sea contents can vent into the void unaided. A vessel entering Saturn's domain might just dispatch biocontainers toward those geyser zones, relying on innate launches to propel them skyward, with portions eventually cascading back to the crust. In millennia, select containers could seep via cracks into the depths, reaching livable zones sans the need for the craft to touch down or breach the ice. This underscores how extraterrestrial dispersal tactics could diverge from our direct methods. We envision vessels alighting on worlds, unleashing bots, extracting samples, tactile, immediate tactics. Yet a culture thinking in eons might opt for indirect means, positioning releases where ambient forces gradually convey them to goals. Such forbearance sidesteps complex descent tech, harnessing gravitational chemistry and geological forces take the lead. Should future expeditions to Enceladus manage to gather and examine plume ejecta in greater detail, revealing genuine life within its subsurface sea, we'd face a pivotal dilemma. Did that life evolve on its own, or was it introduced from elsewhere? Parallel origins on Earth and Enceladus alike would indicate that biology arises readily, bolstering the notion that the galaxy brims with living systems. On the other hand, evidence of seeding, perhaps uncovered via genetic sequencing that uncovers matches too exact for mere parallel development, would confirm exchanges between watery realms, whether by chance or intent. Humanity's role in this vast biological network would transform from singular gem to commonplace element. Life wouldn't be ours alone, and it might not even have started here first in our solar system. Imagine if Enceladus's biosphere predates Earth's beginnings. The revelation would ripple through our psyche in layers, shrinking our perceived centrality even as it broadens biology's reach across the stars. The image of three atlases bearing microbial payloads loses its edge in a cosmos where ocean-bearing moons offer endless niches. Rather than debating if such dissemination occurs, we ponder its frequency and whether our world was ever involved. Could Earth have hosted arrivals with life-bearing cargo that sparked or shaped our evolutionary path? Today's evidence falls short, yet deeper insights into primordial Earth environments and refined molecular scrutiny could someday expose traces of outside influence. This loops right back to the three-atlas timeline and backstory. A probe from the galactic thick disk, aged 8 billion years, might hail from one of the earliest stellar societies, one that emerged when the cosmos was just half its present span and mastered tech amid systems without stable worlds. They couldn't reach Earth, as our planet hadn't coalesced. However, they might dispatch self-activating capsules meant to trigger upon hitting viable setups eons later, safeguarding their legacy through eras that birthed and buried myriad follow-on cultures. Perhaps we're heirs to the galaxy's inaugural minds, offspring of forerunners so primordial that their primal forms have morphed unrecognizably via endless adaptation across varied niches over billions of years. Terrestrial organisms might represent just one limb of a sprawling kin network threading the Milky Way, linked to life in distant ocean moons via a shared engineered heritage. Alternatively, Earth's vitality could stand alone, sparked solely by local geochemistry with no foreign meddling. The cosmos has room for both mechanisms to play out at once, leaving any single planet's origins murky without broader context. Discovery of extraterrestrial life, juxtaposed against our own, alone clarifies our own tale. The surge in Enceladus's organic findings doesn't validate panspermia. It highlights how these ocean realms hold far greater biological promise than we once guessed, heightening the urgency of probes and the odds of detecting life beyond. Local genesis or imported stock? That's still unresolved, pending info beyond our grasp, though the chronology hints at patterns. Enceladus data dropped in September. Three-eyed Atlas nears its solar closest approach in October. These happenings overlap, forging a storyline bond despite no direct tie. Just as we uncover fresh life potentials in our system, an extrasolar wanderer, maybe life-toting, swings to its nearest sun pass. Mere chance or something aligned? Haphazard sync or hidden orchestration we can't yet parse? Perihelion looms, delivering insights or fresh enigmas based on three Atlas's secrets. Meanwhile, Enceladus lurks under Saturn's icy bands, geysers venting, depths roiling, perhaps cradling life older than our species, biding time until our tools catch up. Our solar neighborhood buzzes more than imagined, pulsing with prospects and ties, far from barren solitude. It's a hub of stellar crossings. Ready or not, we're woven into mechanisms dwarfing worlds or suns, ensnared in Milky Way flows predating our birth. The real puzzle? Are we mere watchers of these currents, or poised to shape the unfolding drama? Part 13. Comet Swan 2025 R2. The stellar alignments pile up. Late September 2025 saw hobbyist stargazer Hiroshi Takahashi tapping the solar wind anisotropy instrument via open-access citizen science spot yet another comet heading sunward, tagged C/2025 R2, Swan, per convention. Early scans painted it as a standard long-period visitor from the Oort cloud. Nothing out of the ordinary at first glance. Beyond mere novelty, every fresh comet stirs curiosity in astronomy circles. Yet as global observatories started monitoring Swan or 2, peculiar traits surfaced that mirror some of 3 Atlas's enigmatic qualities. This comet evolved quicker than forecasts anticipated. Its luminosity surged at a pace unusual for something so far from the Sun, hinting at either an overlooked core dimension or exceptionally vigorous venting. Come early October, Swan R2 became discernible through hobbyist scopes, revealing a vivid green hue akin to 3 Atlas's distinctive sheen. While green-tinted comets aren't uncommon, as noted before, thanks to diatomic carbon's typical role, having 2 with prominent green displays at the same time veers from routine into unlikely territory. Not unheard of, though. A comet's makeup hinges on its birthplace, which can group similar traits in clusters. Thus, several from comparable zones could exhibit odd shades. That said, the resemblance prompts scrutiny. Swan 2's orbit might cross paths with meteor streams from past comet remnants, opening chances for ground observers to witness particle clashes. Forecasts indicate its tail could sweep areas dense with Taurid or Geminid meteors, possibly sparking observable encounters as new comet bits blend with aged rubble. Spectra from Swan R2 reveal a carbon dioxide prevalence echoing 3 Atlas, albeit milder. Water ice shows up, yet faintly, yielding a nebulous makeup that strays from standard long-period comet norms. Once more, feasible by nature, merely noteworthy in its deviation. For those inclined toward conspiracies, Swan R2's arrival timing stands out. 2 atypical comets nearing the inner solar system at once, both with offbeat compositions, both sporting matching green tones, showing up mere weeks apart. Such synchronicity fuels talk of synchronized entries, like various probes slipping into the system as a unified operation. Experts highlight that the Oort cloud routinely ejects comets sunward, with dozens of fresh finds common yearly. Many stay dim and ordinary. Now and then, several vivid ones pop up in quick sequence via sheer chance. History boasts grander comet parades, such as 1996 to 1997, when Hyakutake and Hale-Bopp dazzled unaided eyes just weeks asunder. Still, Swan R2 goes beyond a routine Oort cloud visitor coinciding with 3I Atlas. It joins as yet another oddly acting comet with compositional quirks, emerging right when 3I Atlas nears perihelion. This temporal clash weaves storylines that linger, despite data deeming it pure happenstance. Theorists posit a swarm ingress, a cluster of extrasolar bodies invading as a convoy, not lone wanderers. Here, 3I Atlas forms one piece of a deliberate incursion, with Swan R2 perhaps another scout, or a genuine comet guided by synthetic herding tech. The whole inner system faces heightened traffic due to some cosmic occurrence or deliberate choice, timing multiple approaches now. Researchers rebut that Swan R2's path links solidly to the Oort cloud, not beyond, confirming its homegrown status. Conspiracists retort that orbital backtracking errs, or the thing lingered in the Oort cloud post-interstellar journey, localizing its recent path while sourcing afar, proving no ancient capture into system loops, lost to ancient skies, is impossible. The glow likeness between Swan R2 and 3 Atlas sparks talk of common makeup or design. Should both be artifacts employing alike drives, exteriors, or signal traits, they'd appear alike from afar, even as distinct units. Reusing reliable tech across missions beats bespoke builds each time from an engineer's view, where the green simply signals carbon processes, and we're spotting false links. Like spotting figures in vapor or plots in disjoint happenings. Our brains thrive on forging ties, sometimes excessively, spotting links amid mere chaos. What might validate the swarm idea? Spotting the emergence of further items displaying comparable irregularities exceeds what mere chance could account for. Apparent signaling or interaction among distinct entities. Path alterations indicating shared perception and intent. uncovering extra pieces or components detached from either 3 Atlas or Swan R2 that reveal engineered designs or functions. So far, none of these developments have materialized, confining conjecture to the domain of potential rather than proof. Still, the puzzle persists. Why these particular comets at this moment? Statistical groupings do occur, with haphazard incidents clustering by pure luck. Yet, is that the full story? Imagine 3, 4, or 5 atypical comets showing up in the same month. Would that surpass the limits of happenstance, compelling us to recognize some orchestrated activity? At what point do the irregularities outweigh the odds of natural origins in favor of deliberate creation? With Swan R2 and 3 Atlas, we're still in territory where standard astronomical analysis suffices without resorting to extraterrestrial artifacts, though nearer to that boundary than ever previously. Nearing the point where compelling proof aligns with the bold assertion. Swan R2 keeps drawing nearer, growing brighter under intensifying solar radiation, forming its tail, an envelope in line with the principles dictating comet dynamics. Monitoring persists. Spectral data builds up. Orbital paths sharpen. In time, we'll determine if this comet stays unremarkable from a scientific standpoint, despite surface resemblances to 3 Atlas, or if it unveils its unique quirks demanding interpretation. That unresolved tension fuels curiosity. Do these oddities stem from coincidence or design? Our minds seek order and purpose, resisting the idea that chaos can mimic meaningful links. The simultaneous arrival of 2 verdant comets might just be happenstance or a hint that we're amid an event far grander than acknowledged. 3 Atlas reaches perihelion in mere days, with Swan R2 trailing by weeks. Should both proceed typically near the Sun, exhibiting routine comet changes aside from early compositional quirks, the everyday account prevails and theories recede. But if one displays startling deviations, such as breakup exposing internals, path shifts, or component releases, then prior curiosities demand fresh scrutiny under the lens of verified artificiality. We observe patiently, scopes trained on the heavens, gathering light particles that journeyed countless kilometers to inform our perceptions, striving to unravel the photon's message on existence's essence and our solitude in it. Part 14. Close Call Space Rocks. Beyond far-off comets and visitors from afar, the cosmos teems with stones. Countless near-Earth asteroids intersect paths that occasionally skim perilously near our world. On October 10, 2025, a certain boulder, labeled 2025 TF, zipped past Earth at about 100,000 kilometers, tighter than lunar distance, and squarely in satellite territory. 2025 TF evaded spotting until October 9, some 36 hours prior to its nearest pass. Such late discoveries are common for modest asteroids, those 10 to 30 meters across that barely bounce back sunlight and hail from angles blinded by solar dazzle. The rock sailed by without issue, adding to our tally of overlooked threats that materialize abruptly. This blind spot turns alarming in context like 3 Atlas debris possibilities. If a 10-meter chunk slips notice mere hours from encounter, how many tinier bits might 3 Atlas shed undetected? Items 1 to 5 meters wide would stay hidden until atmospheric entry or collision, too dim and compact for today's scouting scopes. Experts in planetary protection have advanced greatly in mapping bigger, risky asteroids, those over 140 meters that could wreak havoc on regions. Surveys now track over 90% of such sizable near-Earth threats, offering years of advance notice for city-endangering behemoths. Yet diminutive ones largely escape inventory. Millions of 10-meter orbit crossers likely exist, with just a sliver documented. Impacts from them wouldn't doom the globe but could level districts, trigger waves from sea strikes, or spark local disruptions, and we remain sightless to most until impact looms. Herein lies the probing alarm of the dormant explorer theory. Should 3-2 Atlas have dispatched minor units past Mars or sooner on its inbound leg, those units might now pursue separate routes to Earth or elsewhere, unseen. These interstellar visitors could evade our present monitoring tools, lurking on unpredictable trajectories since we remain oblivious to their presence. Such units don't require massive dimensions to fulfill diverse objectives. A 10-meter entity holds hundreds of tons of mass, plenty for intricate payloads, assuming the tech behind it is highly refined. Gear for signaling, monitoring devices, or even self-replicating setups could squeeze into spaces that elude our scans until they spring to life. Our planet's orbital zones might already shelter these concealed items beyond our awareness. At geosynchronous heights of 36,000 kilometers, countless operational satellites buzz around, yet oversight of that zone stays patchy at best. Stealth-engineered craft, with low reflectance surfaces and minimal output, could blend seamlessly into the orbital clutter of junk and active hardware. The notion that one might already be circling up there sparks intense unease, and rightly so. It's tough to dismiss outright. Global tracking arrays spot sizable, shiny objects, but their sensitivity misses plenty. Something car-sized or like a freight box, sheathed in radar-scrambling coatings and tucked into busy orbital crowds, could dodge detection for quite some time. The idea of dormant scouts implies a wait-and-wake pattern tied to certain cues. Thus, a device could linger motionless for months or years, emitting nothing unusual, then abruptly ignite and follow its coded directives. Spotting it post-startup gets simpler as powered elements leak radio waves and such. Yet that startup could signal the operations already underway. This wariness isn't wild hysteria. It's a grounded evaluation of feasible blind spots and what clever foes might pull off. Facing tech from society's eons ahead, millions or billions of years, we're downright mild in supposing they can tuck tiny assets near our world. The shortfall in protocols stands out starkly. Safeguards against cosmic hazard zero in on inert dangers like rocks and icy wanderers on gravity-driven paths we can forecast. They're not built for cunning intruders that dodge, team up, or thwart our probes and chasers. Should 3-2 Atlas prove to be a launcher for such units, our setups fall short against that kind of peril. Catching launch moments demands non-stop vigilance with gear tuned for quick high-thrust bursts or splits. Following the scattered pieces needs round-the-clock sweeps of vast spaces our tools can't fully patrol. We lack readiness for this not from oversight, but because gearing up for every slim chance. Game-changing risk drains budgets dry. Still, that math might merit revision amid mounting signs of odd encounters. Overlooking a synthetic source for 3-2 Atlas could spell disaster if we're off base. With stakes this lopsided, better to err on the side of vigilance if units are slipping out unnoticed. We'd do well to scrutinize 3-2 Atlas closer, allocate extra scope hours, handle it like possible alien outreach instead of standard stargazing. Low odds or not, the fallout scale calls for stepped-up measures. Whether such steps unfold in secret compartments is anyone's guess for outsiders. The Space Force runs orbiters with undisclosed tricks up their sleeves. If 3-2 Atlas worries them, it stays under wraps. Linking back to those Mars Trail sightings ties the worries together. Suppose that trail marked a unit release. If 3-2 Atlas shed something en route to Mars, the action phase kicked off already. Additional units could have followed, unseen amid the stellar glow, fanning out through the sun's inner domain toward chosen spots. Probes might encircle us even now, eyes observing, setups priming for go time. While we stay blind, our gear never meant to snag them. The 2025 TF episode underscored that the void isn't vacant. Stuff zips past Earth routinely, and spotting it isn't assured till it hits. Should those things turn smart and multiply, should fleets birth clusters from faux comet hulls, our shields offer scant shield. The clock ticks down to bolster them if the need arises. Perihelion looms in mere days, prime for any unit drops when power surges and aims align best. We're smack in the peak risk stretch, the prime window for launches if they happen at all, and we're hanging fire. We're mostly observers at this stage, with scopes aimed skyward, gathering info, poring over visuals, and holding our breath for whatever the cosmos decides to unveil. True protection demands spotting the danger and embracing drastic steps as necessary. That hasn't hit us yet. We're stuck in the evaluation stage, where careful science trumps pressing safety concerns. Perhaps that's the smart way forward. Perhaps 3 Atlas is merely a comet. And all this worry stems from baseless suspicion fueled by wild speculation and scant proof. Yet perhaps we're on the verge of discovering that excessive prudence turns disastrous when it blocks readiness for dangers that prove genuine. Asteroids keep arriving, spotted at the last minute or not at all, underscoring that the heavens harbor risks we miss until they're upon us. It may not make much difference if those risks are stones or scouts, organic or engineered, as long as we're caught off guard for either. Part 15, the last stretch. We've hit the conclusion of this probe, or at least the limit of discussion before perihelion compels the cosmos to play its cards. The big moment looms in mere days, the instant when 3 Atlas swings nearest the sun, enduring peak heat strain, peak energy surge, and peak chance for some breakthrough or letdown ahead. Time to tally the evidence. Those mass projections hinting at billions of tons might occur naturally, but strain the bounds of ordinary comet makeup. The path's steadiness over an interstellar trek demands an improbable backstory. Oddities in the Mars close-up photos might stem from data compression glitches, though the formal accounts kept evolving. The quirky makeup, loaded with extra carbon dioxide and nickel, strays from usual patterns. That green shimmer seems exceptionally bright. Surviving the coronal mass ejection points to toughness exceeding flimsy rock heaps. Potential path tweaks display angles that don't fit natural gas bursts. The 8 billion-year vintage suggests ice endurance that's flat-out implausible. The arrival syncing with our detection tech raises eyebrows. No single quirk clinches an engineered source. Each boasts organic rationales that hold if you buy into a string of rare but feasible scenarios. Yet the combined load of all these oddities piling up at once forms a trend that's tougher to brush off. Eventually, the organic theory needing a dozen improbable twists grows less likely than the engineered one needing just a single. That 3 Atlas serves as a scout. Most experts aren't there yet. The prudent view calls it a fascinating item ripe for in-depth exam, but lacking solid proof of man-made roots. The bolder take flags way too many warning signs to overlook. Both stances hold water based on current info. 3 paths outline the potential outcomes. The hours-long path kicks in if perihelion sparks something flashy. Instant breakup exposing the core, abrupt path shifts signaling engine ignition, module launches spotted live, or signal bursts riding solar energy. Should any unfold, we'll grasp within hours that it's no natural wonder. The weeks to months path fits subtler shifts. Follow-up path checks needing time to spot quirks, debris scans uncovering weird materials, or released parts emerging as they spread out. This window permits expert vetting prior to going public. Group debates on framing the news. The year or more path suits if zilch stands out. 3 Atlas clears perihelion and arcs away, acting like a standard comet as theories of artifice wane with fresh data debunking them. That covers chances of postponed startups, with scouts biding time, months or years post-perihelion, before kicking off tasks. Each path links to key sparks. Perihelion hits October 28, 2025, when sun warmth crests and heat pressure peaks. Tail breakup or piece shedding would show up in days. Acceleration quirks after perihelion would surface in weeks via building path reads. Focusing on enduring this buildup now is vital. This isn't a recap of bygone happenings. It's a live, ongoing drama where each day yields fresh sights and possible insights. At this very moment, scopes are following 3 Atlas. Right this instant, gear is snagging light patterns and snapshots. Right now, something tangible is unfolding amid Mars and the Sun, and we're witnessing it unfold. The direst outlook features a module fleet unleashing at perihelion. Scores or hundreds of pieces peeling off the core body and vectoring to diverse spots across the inner solar system. The fleet fans out fast, with lone modules being tiny and shadowy to monitor it reliably. It fades into the immense expanse of the solar system, following directives set eons ago, millions or even billions of years in the past. The moderate scenario positions 3I Atlas as an impressive comet, offering a wealth of scientific insights without posing any real danger. Its peculiar makeup reveals lessons about the conditions where interstellar bodies form. Pieces that break off enable hands-on sampling or spectral examination of its core makeup. Human society remains unchanged at its foundation. We simply gain deeper understanding of comet mechanics. This seems the most probable result, drawing from our encounters with Oumuamua and Borisov. Each sparked plenty of conjecture, but turned out far more routine than remarkable. The optimal outcome varies by viewpoint. Purely from a research angle, the ideal is a functional probe eager to exchange data, sharing details on its source, creators, and purpose. Initial encounter with extraterrestrial minds. Even if those minds perished ages ago, the insights would transform disciplines ranging from physics to philosophy. On the defense side, the ideal is verifying it as a pure natural comet via thorough observations, quashing all doubts. Risk nullified, fears eased, efforts refocused on genuine issues. The key message for observers is that vigilance persists indefinitely. 3i Atlas won't be our final brush with interstellar wanderers. Observation scopes are advancing, spotting skills broadening, and incoming travelers will show up more often. Every fresh entrant sparks the same rounds of guesswork and scrutiny, slowly compiling evidence that either validates their natural origins or piles up oddities hinting at crafted designs. We're caught up in an age-old drama. Be it the timeless laws of physics unfolding over billions of years or sentient beings extending influence galaxy-wide to graze our realm, the vastness defies grasp, yet the moment is upon us. At this instant, overhead in our skies, a traveler from unfathomable realms is crossing our local space, and we possess the tools to observe its journey. That feat alone marks a stunning triumph for humanity, no matter what 3i Atlas ultimately reveals itself to be. Just 100 years back, we scarcely grasped the existence of distant galaxies. Half a century past, we'd never spotted an interstellar intruder. Now, we follow their paths, probe their structures, question their essence, and earnestly ponder if they could embody foreign tech. The closing punch lands the intrigue. If the whispers hold water, how much time remains? The timer has started. It's happening in the present, with urgent implications, compelling us to face that answers will surface shortly, not in some vague tomorrow, but right here, this month, amid your everyday routine, oblivious to the cosmic gamble unfolding. Perhaps we've got endless days ahead since 3.2 Atlas is merely a comet, posing zero peril. Perhaps mere months or years before launch components achieve full function. Perhaps no buffer at all. Components already in place, merely awaiting trigger commands. The ambiguity drives it home. We lack certainty. For all our scopes, breakdowns, and theories, we truly haven't a clue what 3i Atlas is or what unfolds thereafter. The cosmos is set to disclose it. Prepared or otherwise, closest solar approach looms. October 28, 2025. The suspense wraps up. The reality, come what may, starts unveiling in light and darkness, in paths and light signatures, in the coming or lack of the transmissions we've scanned for. The timer ticks on. What's our window? Days to closest approach? Weeks for the after-pass reviews to wrap? Months for expert agreement to solidify? Years till the subsequent interstellar guest drops in and the pattern restarts? Or perhaps time's up entirely, and the shift hits before you glance skyward, before folks catch on that the buzz was spot on and the final count slipped by as we debated its validity. The entity persists out there, shifting, nearing its pivotal instant. And we sit here, observing, anticipating, questioning if this tale will echo in annals as the turning point, or merely another sidelight in the endless chronicle of spacefarers that drifted by, bequeathing only records and dimming theories. The verdict nears. The cosmos prepares to whisper. Whether we're set to listen to its words, well, that's another matter altogether.